Hi, good morning students. This is Harsnath Sukla and today we are going to discuss lecture number 4 for the chapter. Lecture number 4 for the chapter Continuity and Differentiability. Continuity and Differentiability. In this lecture, generally we discuss the continuity of composition of two functions. So, what is the continuity of composition of two functions? Two functions. If f and g are two continuous functions, f is continuous at x and g is continuous at fx, then we can say f composition g is continuous function. Always remember, f is continuous at x and g is continuous at fx, then we can say f composition g is continuous function. This particular composition of function used to solve some different type of questions, suppose mod of sin x. Okay, what is the continuity of this function? So as you know, at x sin is continuous, that means f is sin x, fx is sin x, so sin x is continuous. Then if we consider fx gx as a mod x, okay, so g of fx, that means g of fx, that means mod of sin x. So this is what? F composition of g. So as x is continuous, gx mod x is continuous, so we can say f composition g, that means mod of sin x is also continuous function. This is useful to solve last questions of exercise 6.1. Later we discuss. So we just try to solve this type of problem. See, some questions are there. So that the function defined by fx is equal to cos x square, fx is equal to cos x square, question number 31, question number 31 from NCERT exercise. So let fx is equal to cos x square. So that the function fx is equal to cos x square is a continuous function. So how to show this is the continuous function? So let us fx is equal to, let fx is equal to x square and gx is equal to cos x. Okay, gx is equal to cos x. So as you know, fx is continuous because x and x square, because being a polynomial function, this is continuous. So what about the gx? So gx is gx is cos x. So You know very well this is also continuous. So f composition of g, that means g of fx. Okay, so g of fx, and what is fx? X square. And what is gx? Cos x. So g of this is cos of x square. So this f composition g, being f is continuous, g is continuous, so f composition g is also a continuous function. So you can say, right in this manner, this particular function is continuous. Okay, so next one. So that fx is equal to mod of cos x. Similarly, question number 32, show that fx is equal to mod of cos x is a continuous function. So show that fx is equal to mod of cos x is a continuous function. So there are two functions, actually composition of two functions. First, fx is equal to, suppose, mod x, and gx is equal to cos x. As you know, gx is continuous, fx is equal to mod x, this is also a continuous function. So if we consider f composition of g, that means g of fx, so this is gx, this is what? Cos x. So sorry, g composition of f, here you take g composition of f. So f of gx, so f of gx means f of this is x, so this is mod of gx, and gx is what? Cos x, so mod of cos x. So this is the composition of two functions. As you know, these two functions are continuous, so composition of these two functions are also a continuous function. So in this manner you can show this is the continuous function. Similarly, some more problems are there, like sine of mod x. This is also a good question. Sine of mod x. Sine of mod x. Here the choosing of the function is important. We can discuss for sine of mod x. So fx is sine x, and now gx is mod x. So f composition g, that means g of fx. So g of fx means mod of g of fx. fx is sine x. So g of fx, g of sine x, and this is, sorry, you can consider f composition. This is the choosing of the function g composition f. So f of gx. So f of x is sine x. So sine of gx it is now. This is sine of gx. Gx is what? Mod x. So see, this is sine of mod x. So you can say here sine of mod x is continuous function, being sine x is continuous and mod x is continuous. So in this manner we can say g composition of f, that means f of gx is a continuous function, because composition of two functions are again a continuous function. Now next one. Find all points of discontinuity. This is the last problem. See, find the all point of discontinuity. Example, problem number 34. Find all point of discontinuity for the function defined by fx is equal to mod x minus mod of x minus. simply you can write here mod of x plus 1. As you know, sum of two continuous function is again a continuous function because algebra of continuity you already seen book, and difference of two continuous function is continuous again if both the functions are continuous. If one of them is discontinuous, then sum and difference is again a discontinuous function. So you can see from the book continuity of sum, difference, product and etc. of the function. So if you see here mod x, if you see for mod x, this is absolute value function. So this is continuous everywhere, you know very well, continuous function. And mod of x plus 1, this is also a continuous function. Hence fx is equal to sum of these two functions mod x minus mod of x plus 1. So sum and difference of two continuous function is again a continuous. Hence we can say this is also a continuous function. So there is no point of discontinuity for this function. So let us see some more questions and then wind up this particular topic, continuity, and in next lecture we are going to start differentiability. So let us see some more questions. Problem number 26. This is already asked in the board. So problem number 26. Find the 26 to 29, same problem it is, but we are just going to discuss problem number 26. Find the values of k. This is NCERT problem, so please try to see your book. NCERT question number 26. Find the values of k so that the function f is continuous at the indicated points in the problem 26 to 29. So first problem 26 we are just going to write here. So see problem number 26. Problem number 26. First we write the question. Fx is equal to k cos x divided by pi minus 2x if x does not equal to pi by 2. This is 3 if x is equal to pi by 2 and x is equal to pi by 2. This function is continuous at x is equal to pi by 2. Hence we can find the value of k so that the given function is continuous at x is equal to pi by 2. So let us see. First of all we find LHL, RHL at this particular point, then value of function. So LHL. Here one most important thing, in last lecture or that particular lecture or any lecture we shall discuss we had already discussed the questions of the type where the function defined for less than, greater than, but here not less than, greater than, here does not equal to. So whenever this type of function is defined, so either x is greater than that particular point pi by 2 or x is less than pi by 2, you shall consider the function as does not equal to, because either greater or less but does not equal to pi by 2. So in the both the cases we shall consider the function as x does not equal to pi by 2. So LHL of this function, limit x tends to at x is equal to pi by 2, we shall discuss the this function is continuous. So at x is equal to pi by 2 we shall find RHL and LHL. Pi by 2 minus fx, that means limit h tends to 0 f of pi by 2 minus h. So pi by 2 minus h, as h greater than 0, so this is the quantity less than pi by 2. but here function is not defined for less than pi by 2. So you can apply the common sense. Pi by 2 minus h is less than pi by 2. That means that will be not equal to pi by 2. So function is not pi equal to pi by 2. So we consider this function. So limit h tends to 0, k means constant, and this is cos of pi by 2 minus h, and divided by pi minus 2, pi by 2 minus 2 times pi by 2 minus h. So if we find the limit h tends to 0, k sin h, this is pi minus pi and divided by h. You see, pi minus this is pi and this is 2h. Okay, minus of minus plus, and this is 2h. So this is limit h tends to 0. As you know how to find limit, we multiply and divide by this is 2, so we can write it as k by 2 sin h by h. So this is k by 2, and you know limit h tends to 0, this is sin h by h. So this is 1, you know already from class 11. So this is k by 2. So LHL is nothing but k by 2. Similarly, we find RHL and then value of function, and then we will get the value of k. So I hope you understand this one. See, k times cos pi by 2 minus h minus pi minus 2 at the place of x, pi by 2 minus h. So after calculating, we will get this result. Now RHL, we need to find RHL. So see here, RHL, right-handed limit. So RHL is nothing but RHL, right-handed limit. Limit x tends to pi by 2 plus f of x, limit h tends to 0, f of pi by 2 plus h. So again, for pi by 2 plus h, this is the quantity greater than pi by 2, and there is no function defined for greater than pi by 2. So this does not equal to pi by 2. So we can consider this function. So limit h tends to 0, k cos of pi by 2 plus h, and divided by pi minus 2 times pi by 2 plus h. So this is limit h tends to 0, k minus of sin h cos pi by 2 plus h. In the second quadrant, only sin and cosec are positive. So this cos pi by 2 plus is minus sin h, divided by pi by 2 minus pi, this is cancelled, minus 2h. So again we will get limit h tends to 0, k by 2 is out of the limit, sin h by h. Then from first year sandwich theorem, we will get k by 2, this is 1. So k by 2 into 1, this is also k by 2. So this is the RHL for this particular function. Now we are going to find the value of the function. So what is the value of the function? We can see here. So f pi by 2 is nothing but, you just clear here what is the limit of the function. Limit of the function is k by 2. So f3, value of the function f pi by 2, this is nothing but, I'll exclude pi by 2, this is 3. So since function is continuous, so LHL is equal to RHL, and this is equal to value of function. So we can here k by 2, and this is equal to 3. So from any of the equation, k by 2, 3 is equal to 3. So k is equal to 6. In this manner, we can find the value of k. So same type of question is there from 26 to 29. So I hope you are going to solve this type of problems and get the answer. So thank you for today, and in this manner we have to complete our this topic, continuity of the function. So in next lecture we are going to discuss the differentiability of function. So thank you very much.